Okay, everybody, welcome to the Adaptive Computing webinar, Why Adaptive Computing in Oracle Cloud Infrastructure. My name is Sue DeGram, and I'm Director of Marketing here at Adaptive Computing. And I'd like to thank everyone for taking time out of their day to join us. I'd like to introduce our panelists that we have today. Riaan Venter.
My name is Riaan Venter. I'm a Senior Solutions Engineer at Adaptive Computing. I am responsible for working with our pre-sales, sales teams, development teams. Have been with Adaptive Computing over 2 years now, and looking forward to talking to you about our solution for you today.
Great. Another panelist that we're really excited to have with us today is Anup from Oracle Cloud. And Anup, could you introduce yourself, please?
Hello, everybody. My name is Anup, as you mentioned. So I'm a Senior Manager for the Global HPC Cloud Engineering team at Oracle. I'm responsible for all things HPC in the cloud. Happy to be here with Riaan and Sue, and I'll spend some time, maybe after Riaan is done, I'll just introduce you to Oracle Cloud and how we do HPC.
Great, wonderful. Okay, Riaan, I'm going to make you the host now and let you go ahead and get started.
Right, okay, thank you, everybody. So as Anup mentioned, I'll do the first part going through on-demand data center. I've got a few slides that we'll go through, and then I'll do a short demonstration, and then after that I'll hand over to Anup to cover the Oracle side first. For people that are not aware of adaptive computing, adaptive computing has come a long way in the high-performance computing industry, and we've got some advanced applications and tools to assist the high-performance computing environments. You'll notice that we work in most of the industries or the industry verticals, looking at things like oil and gas, life sciences, manufacturing, universities, research labs, especially people doing, especially if you're talking about the scientific labs that require high performance kind of environments to be able to process their workload, and especially with our, let's call it our legacy products. That's called Moab, which is very well known in the industry. We've, over the last few years, started building on-demand data center that extends that functionality to assist people to move their workload from the on-premise environment into the cloud. Now, if you look at some of our customer base, you could notice over here big organizations in the United States like the CIA, Halliburton, Northrop Grumman, and so forth. So just some of the names that we work with and currently are using our solutions. Now, focusing on more specifically on the on-demand data center environment, on-demand data center is very flexible and scalable, a cloud management platform that we use to assist you in deploying, monitoring, scaling, shutting down of cloud resources. If you look at some of the key points, for example, cluster elasticity. So, that's important in the sense that, for example, if you've got a cluster that's got, 10 nodes and you've got more workload coming, that we can actually, if you choose that option, if it's switched on for you, we can resize your cluster. Now, we've also built in support for containers, as you can see on the screen, Kubernetes, Singularity, Docker. That's all by default now already available as part of our stack build, as we call it. So it will be available out of the box. And then, typical areas where people talk about, how do I get access to my data from file systems? We've got something called data anywhere, meaning it doesn't matter where your data resides, whether it's on-premise, in the cloud, you can actually access it from anywhere. And some of the let's call it commonly used file systems like BEGFS and NFS is also by default available when we deploy clusters, and you can add any additional ones that you prefer. Now, I'm talking about Moab, which is our HPC scheduler, but if there's no scheduler, you can run your workload directly on on-demand data center, or you can use another scheduler to interface with on-demand data center. We have done extensive testing, especially when we're looking at our bursting functionality, which I'll talk a little bit more after in the next few slides. You have at least a 50% cost saving when you have a cluster in the cloud. You've got, for example, 100 nodes, but you only have a head node up. All your compute nodes are actually down and only will be started up when workload comes in. So that's where your cost saving comes in. I mean, there's other key features like making your cloud environment portable. You can move it around between providers, between different instances, and this is where on-demand data center assists you a great deal. Now, again, we've made the user interface, the ODC user interface, very easy to use. You don't have to have any cloud knowledge. It does you just have to configure your cluster and click a button to say deploy it, and we'll actually deploy it within that service provider that you choose. And then if you're talking about some of the, let's call it the use cases, especially nowadays and especially in the HPC world, people are talking about hybrid IT. The HPC market or industry has been fairly cautious about moving into the cloud. But we've seen it over the last few months, a lot of them talking about they need to do that, but then they can take an approach of having some on-premise and some in the cloud. You have a hybrid environment doing that, and also while you are running in the cloud, you can use the bursting functionality from on-demand data center. And as I mentioned earlier, especially on the artificial intelligence, machine learning, deep learning, data analytics, all those environments are key for people nowadays with types of processing they require. And this is where you could use GPUs as example from a service provider to assist you with running your workload where it requires high performance resources. And then obviously I like to use a good example which we talk about in DevOps environments, especially in the enterprise world, where you've got a group of developers working on their code, and they do have access to cloud resources, but at the end of the day they don't really watch or monitor or manage their resources. They just knock off, go home, and then those resources remain on the cloud 24/7. So that means by using the on-demand data center functionality, we switch on bursting. So as soon as they do finish off, it's an all automated process where your on-demand data center will actually, based on as we call it, an idle purge time, take those resources down. So it assists you a lot with managing your cloud environment, and it saves you that 50% at least. So it gives you a big cost saving and not paying on resources that remains in the cloud. Now, as I mentioned, the cloud bursting, that's very important for us in the sense that it adds a huge benefit when you use on-demand data center. Now, obviously, you could have a cluster that's persistent, fixed, even though that means, and we do have customers preferring that, you could still have the capability of making your environments portable, having a persistent cluster, or using bursting, and there's different options, minimum, maximum. Minimum means we run your workload sequentially, meaning we'll take care of it, but it will take a little bit slower, but that's more from a cost saving point of view. And when you use maximum bursting, it will assist you in getting everything done as quick as possible. In other words, give me everything that's available on a cluster based on what's configured, and it will give you everything that's required until your workload is done. So that's just getting things done as quick as possible. And then we've got an all option that sometimes somebody don't care about minimum, maximum, just irrespective, even if I've just got 5 jobs, 100 nodes, give me everything. So that's your all option. And then there are built-in options like on demand that you just have a user that just want to run something quickly, not worried about having a cluster already configured running in the cloud. Use the on-demand app option, and that actually assists you in configuring a cluster, deploying the cluster, running a workload, and getting rid of that cluster immediately. Now, if you look at the bursting from a diagram point of view. And also note at the top where you say cloud bursting configuration diagram, there's a patent number. Our CEO recently received the patent on bursting functionality for on-demand data center. Now, in this slide, you'll notice on the left-hand side, we're talking about, which I spoke about, minimum, maximum, burst all, and a persistent cluster. And I mentioned the on-demand option, where you could just have a quick job that you need to run, workload you want to take care of, and you've got different options even on the on-demand side that you can actually say, well, all right, just run my job, get rid of the whole cluster, or when it's done, just bring down my compute nodes, keep my head nodes up, and that's more putting it back into a bursting state. So different options available from the on-demand data center environment. Then just briefly talking about the process that we follow. First of all, you select your cloud provider, and you have to have credentials, valid credentials, to be able to deploy a resource in that provider. And then we have a base stack that consists of a set of software that when that's the next step. So that's even before you do a cluster deploy. If you run our base stack, which consists of that set of software, which includes things like MPI, OpenVPN, certain applications already included, you run that and it creates an image within the service provider. And that image is then used on step 3 when you actually configure your cluster. So you use the prefix from that image in your cluster configuration. And you define your cluster, how many instances, which instance types, and as step 4, you just go ahead and do a deploy of that cluster. So that's really a fairly straightforward, simple way of getting your workload into the cloud. And I would say 1, 2, 3 maximum hours you could get on-demand data center up and running, cluster configured, and have your workload running in the cloud. Now, this is just a single pane of glass where you can actually see everything from one place. We're talking about a multi-cloud orchestration, meaning you can have multiple service providers that you can manage from one place. Also, we know some people prefer using the command line interface compared to the user interface, or vice versa. For that, everything that's available in the user interface is available on the command line interface as well. And just as how it works, which I've spoken about. So on the left-hand side, you'll notice you'll have your job scheduler. In this case, I'm going to use Moab being hours on-premise, and then we've got something called On-Demand Data Center Connect that connects your on-premise with your cloud environment. And this block in the gray is where you've got your on-demand data center up and running. You've got your stack built, and you'll notice that I'm mentioning Oracle Cloud in this case, and this is we've got a close relationship with Oracle, working close with them. Hence, Anup being on the call, that he'll be talking about the Oracle side as well, adding huge benefits to both our sides as well as them. And we do recommend that everybody look at Oracle as a service provider. This is where you deploy and configure and deploy your cluster. It really just brings all of this all together in this diagram. Now, for the demo that I'll be doing, I'll be running a workload from our Moab on-premise scheduler. I'll be submitting 20 jobs using a script, and I've already got a cluster defined on-demand data center that will actually be aware, or Moab will be aware of those cloud nodes, and it will actually on-premise will be filled up. Then we move it into the cloud resources. Then we jump back to our on-demand data center where you'll actually see that we start taking care of that workload. The important thing as well is there's bi-directional communication between the on-prem and the cloud environment, meaning our Moab environment are aware that even though my cluster may be in a bursting state, it has to put my, it won't run against my wall time, as we call it, so that the job on the on-premise side aren't, discarded afterwards. So while my compute nodes are actually being deployed. So over here, I have my login screen to my user interface. So I'll just briefly show you logging in and what we've got running here right now. So I'm just going to log in, And you'll notice this is a landing page, and I'll go through that just now, how we configure this. Not in detail, I mean, I just want to give you an idea of how it works. But you will notice I've got a cluster over here. I've kept it small and simple, so I don't want to make it too long and too large. This is a cluster that I've configured that's running on Oracle and OCI. It's only got 3 nodes, and it's 3 different instance types. So as soon as I jump back to my Moab environment, you'll notice that they are actually being seen by my on-premise environment. Now you'll notice there's 3 different instance types, make it heterogeneous. It could be any instance types. It could be GPUs, bare metal, whatever the requirement is, and make it part of one cluster configuration. My cluster is actually in a bursting state. I've used maximum bursting, meaning as workload comes in, give me everything I've got available. And you'll notice my 3 compute nodes are actually in a down state. Cluster is deployed and available, but they're actually down, so I'm not paying towards them. And currently I've got nothing in my queue. Right, so now I'm going to jump to my actual Moab environment. So I just want to show you where actually my Moab environment sees this, and I'll just do a command called -n, which you'll notice at the bottom here, this is my on-premise node. It's got 16 cores available, and that's my on-premise resources available. You'll notice a few more, but those are something we call Moab Grid, that actually you can run your workload remotely, so you connect to other instances of Moab or your scheduler. And then those 3 nodes that you noticed, they are all available over here. Moab is aware of them, and as soon as my on-premise environment gets filled up, we will actually start using those. And just to show you my script that I'll be using, I just want to show you that. So you'll notice that first of all I will kick off one job that will actually run, and it will just start the process. Only require 4 processes, and you'll notice I'm using the dependency functionality from a Moab point of view. So these 4 jobs are actually waiting for that first one to complete, and these 4, each one require 4. So it's going to fully utilize my 16 cores on-premise available. And then as soon as these 4 go into a running state, I've got 20 jobs being submitted from 20 different users. And then Moab is aware of my cloud resources, and it will actually start processing that. So I'm going to go ahead and kick this off this time. So just to start the process. So in the first step, and remember, this is one command. I'm not doing anything else. The whole process is all automated. I don't have to do anything. And this is just now Moab's, as we call it, a queue from Moab, same as any scheduler. It will showing me what's currently active, and you'll see I'm just refreshing it every 2 seconds. So this first job is running just to start the process, running for 60 seconds. And then these next 4 will actually go start running after that is complete, because it's dependent on this first one, as you saw in my script. And as soon as these 4 actually go in a running state, my other user jobs, you'll notice the user 1 to 20, also have workload that came in, but now my on-premise environment are fully utilized. So what should we do? So it's a backlog, right? So this is where Moab allocates these jobs to the cloud resources so that they can actually be taken care of as we go along. And we'll see that shortly. And we'll notice that, remember, the queue on the user interface is currently clear. There's nothing coming in there. And we'll just wait for this process to kick off so that we can see how everything starts running. And while we're waiting for this guy to show up here, let me show you. Over here is just a screen of, as we call it, a burst cycle. So that cluster that we were monitoring, it is actually checking every 60 seconds, are there any workload? So this will start changing as workload actually comes in. You'll notice that my jobs are actually being moved over now. So shortly we'll notice that this guy will also go into there, and we'll start getting our user jobs also being moved over. As soon as that happens, we'll notice that now, listen, we've got our user jobs here. What should we actually do about this? And then we'll start taking care of those. So while we're waiting for that to happen, I'm going to jump back to my user interface. And remember, I mentioned that over here, we've got our queue that will start building up. And the process that what happens is as soon as my burst cycle comes along, it will start deploying, first of all, a set of compute nodes that's required. And that will actually then deploy each one of these compute nodes, and they'll follow the process of becoming available, becoming busy, and then starts running, taking care of my actual queue. So I'll just jump back to my home environment. All right, so you'll see that shortly our user jobs will start moving over. And as soon as they start moving over, then we'll see some of these jobs start moving into my on-demand data center environment. Right, so let me show you some of the other environments in the meantime. As I mentioned, there's a credential manager. You have to have your credentials available within, configured within your own on-demand data center environment, and use a simple process of clicking a plus, selecting your service provider, giving it a name, and you generate your credentials from your service provider that gives you access to that environment. And then we run a stack build, which I mentioned. So that actually creates an image within the service provider. And as soon as my stack is built, I can go to my cluster manager, and this is where I configure my cluster. So again, I select my provider, and this is a few steps that you follow. You give it a name, the prefix of my image that I created in one of the previous steps. Then I use that credential, remember my credential that I added. I give it a head node size. Now this is, pretty, we give a small list, but you can imagine from any provider, it could be thousands. So we give you the opportunity to add to that list. Resource managers, you can use either ours, which is Talk, that runs with MoAB, or Slurm. And then there are some, breaking it down further using sub-regions from the provider's data centers, availability zones. And at this stage, you can actually switch on bursting already, or you can switch it on after my cluster has been actually deployed. And then you can switch on bursting, it's your choice. And this is where you add your compute nodes, right? So you can choose different types. So you can say like that. So I want one of these, and I can add one of these, say one of those, and again, different instance types. So just to show you something else, you'll notice a little thing at the top where it gives a dollar value per hour. So if I give it a name, and I give it a credential, and I choose a region, now you'll notice that start changing. It's based on my head node and my different compute nodes. That what it potentially, it's not exact. We know some people have some discounts and so forth. So that just gives you an idea of potentially what you will be paying. And remember, this is before you actually deploy your cluster. So that just gives you an idea of what it potentially would be. So that's when you define your cluster. So it's a configuration that you save, and you can actually reuse that configuration. We've added the option to pull that back so you can save it. Sometimes your configuration is more complex and you prefer doing that. And then it's really a question, you'll notice a few of them are actually down over here. On the right hand side, you just click deploy, and it will go ahead and actually deploy that cluster for you in the cloud. So before I show you one other thing, so you'll notice some of my jobs are busy coming through now. So let's have a look at my queue. You'll notice out of my 20 jobs, there are 5 now queued. Now remember, I mentioned that depending on what is in the job queue at the time of my burst cycle, that's what actually will be deployed. So at the moment there's 6, so depending on what there was at the time, it will deploy one of my compute nodes. And as I mentioned, it will deploy, and then it will become available, and it will start becoming busy, meaning it will take care of this workload of mine. And then it will actually, when it's complete, it will go back to available. Now, I mentioned something called a idle purge. Mine is currently set to 2 minutes, for example. Then I would actually, it will actually wait for that time. For in case there's more workload coming in, right? You don't want to up and down your compute nodes. And then it will start after that idle purge time expires. It will move them into offline state and then start actually destroying them, right? So you'll notice that I'm already allocating some workload to that one compute node that's deployed. And there's interesting that you'll notice over here. You would think it should go under busy. It's only because it's using part of my compute node, depending on what was in my queue at the time. So it will actually allocate that based on that. So it's using 7 of my 16 because there's 9 jobs on my queue. When it's fully utilized, there's 0 of 16 left. It will actually show as busy. So it's just different ways of showing how many cores are still available on my compute node. Now, because they are more available, as more workload comes in, it will actually allocate that against that cores that's still available. So that's the whole process that we follow, and without wasting too much time on all the details about this, I mean, I think you get the kind of idea of what we're doing. Just as a confirmation of how this works from a MOA point of view, but because there's bidirectional communication, as soon as MOA will start getting information from on-demand data center that there is actually compute nodes being deployed, then it will actually put my actual job in a suspended state, because we've got something called a wall time that it shouldn't run over, otherwise we discard it. 1 or 2 other things, and then I'll start handing over to Anup. If I look at my job manager, remember I mentioned you can actually run workload directly from on-demand data center. So we've got, for example, over here, I've got different types of jobs, MPI, just normal test jobs. I want to use one of these examples. One is called Splice AI, is a specific application. I had a request from a customer saying, well, I want to run my job in the cloud, but I want to keep my workload on premise. So in that case, we run the job in the cloud, but then we connect via VPN back to my on-premise environment. We mount a shared file system, and that's where the input data is. We use that. And then as soon as that's completed, we unmount the shared file, and also that output data is written back to that same file server. That's your choice. Or you could be writing it to another place. And then we disconnect the VPN connection. So this is another way of running directly. I call it pure cloud, where you can actually, there's 2 options. You can do a little suitcase over here. You select your job, and you can say against which cluster I want to run it. And depending on how many nodes, how many cores my job actually requires, it will allocate a specific cluster that's actually allowed or can run it. Right, and then again, remember I mentioned over here that there's the on-demand data center. So this is another way, another option of running a job, but over here we've got on-demand. So if I click on that, it will give me the option to define my cluster, it will deploy the cluster, run my job, and actually get rid of it afterwards. And we'll have something called a file manager. So while my workload is busy running, you'll notice that as soon as my workload comes in, we create a file and is busy being used. So that's why it's saying in use. And then as soon as it completes, I can actually view the output of that file. In this case, it's MOAB jobs that came from MOAB. And we write this same output back to the user that submitted it from on-premise on the cloud. So I think I want to leave it at that. If there's anybody that wants to see more in detail, we can do a much more detailed demonstration, but I want to give Anup the opportunity to also talk a little bit about the Oracle side as well. All right, so Anup, I'm going to stop sharing, and then I'm going to make you the host.
Thank you, Riaan.
Okay.
Can someone just give me a thumbs up if you can see my screen?
We can see it. Thanks, Anup.
Awesome. Hello, everybody. maybe one more time just to introduce myself. So Anup Ojah, Senior Manager for Oracle Cloud. With me, I have Riaan Venter. I would like him to also introduce. Riaan, why don't you give a quick introduction, because Riaan and I am going to go through a few of the slides today.
Hello, everyone. My name is Riaan Venter. I've been at Oracle about 6 years. I work as one of the solution architects under Anup, specializing in HPC, working alongside making sure that the partnership with Adaptive is going strong. And I look forward to potentially working with any of you guys interested in adaptive computing's ODDC solution, MOAB solution, and Oracle Cloud Infrastructure in the future.
Thank you, Riaan. I'm just going to leave the screen for maybe 10 seconds, just to save harbor statements. Great. So let me start, going back to some history. So OCI, or Oracle Cloud Infrastructure, we are a Gen 2 cloud. So frankly, AWS has been there for many years, 15 years now, Google Cloud, so is Microsoft Cloud. So they're all generation 1 clouds, but we came back and we decided that we need to build a cloud. And this was almost 5 years back. That's almost when I joined this company. So 5 years back, Oracle decided we have to get into the cloud, but we want to build a second generation cloud, not the same generation 1, because we had the time, right? We really were able to understand how AWS built their cloud, and so does the other cloud provider. So we were able to hire some of the smartest guys from the industry, and they were told one thing: do not make the same mistake. So with that being said, we built Gen 2 Cloud. I'm going to go a little bit more in details what Gen 2 Cloud means and what is the purpose built, who are our customers. But if you look at this global map, this is growing every month. So again, 4 to 5 years back, we started with 3 data centers, 2 in US, 1 in Frankfurt. But today, mostly in the last 3 years, actually, we have seen a rapid growth in the requirements. Why it's a rapid growth? Because the power of the Gen 2 Cloud, customers has realized that what they need to really move an enterprise workload, and in this case, obviously, high performance computing. So with our HPC customers, we have seen really good tractions moving to the cloud. So we were able to deploy new data centers across new geography, across the world. And today we have more than 31 regions, actually. This is in October. I think in November, we have one more in Saudi too that went live. So by end of next year, we will have almost 44 regions across the globe. And that will keep on growing. What it says, the investment that the company is making is all about the cloud. Well, with this for 44 data centers, we also beat AWS because they have less than us. So, that's really a testament of what Oracle is doing in the cloud business. Maybe a quick slide here, just to reiterate that Oracle is really known for our applications. Today, we have our SaaS portfolio. Obviously, we are really the #1 in ERP applications, HCM, finance, all of them runs as a SaaS on OCI. It's the same infrastructure that we give you as a HPC customer. We do have platform services, the PaaS layers, the SaaS, PaaS, and the IaaS. But for today's discussion, I think we'll focus more on the OCI, which is the infrastructure layer at the bottom. At the very bottom, you might also see, commercial data centers. We have Gulf data centers, and also something called dedicated region clouded customer. I'm not going to speak more on the dedicated regions, but there are certain requirements by a lot of different customers where they cannot put their data into the public cloud. So Oracle can build a similar or equal like a public cloud, just dedicated for a particular customer. So that's a pretty bigger discussions. If anybody has interested, please reach out to me and I can spend some more time. Well, I put this slide at the very beginning because if you have to remember one slide, I think this is the slide to remember. the 5 main tenets of the Gen 2 cloud is security, automation, performance, scale, and cost efficiency. And I'll go through all these 5 different, what is security? Obviously, we have built Gen 2 cloud from the get-go with security first. Automation, I think that has been the power of how we have been able to deploy in the last 3 to 4 years so many data centers around the globe. We can go and start building a data center in less than 6 months, frankly. And we have been deploying every 2 months a new data center around the globe. So that's all about automation. Performance, now that's all about what you care, right? As a customer for HPC, so we provide the best performance in the market. And we have, Brian is going to spend some time today to talk about some of the benchmarking numbers. Scaling, obviously, that's very important, and cost efficiency. I'll spend some time how we really go to the market by giving you performance, giving you scale. We also cut cost for you as a customer. So let's quickly deep dive, why HPC in OCI? Well, we've been in this business for quite a long time. So we haven't just built this cloud in the last 4 or 5 years, but we have, a lot of tribal knowledge in this area. So I think it started back when we acquired Sun Microsystems. So from the acquisition of Sun Microsystems, we did 2 things. First of all, we got the IP, how to build hardware. So mostly people know about our Exadata, Exalogic. So they're all based on Mellanox networking. So we acquired those IP from Sun. Number 2, we also got all the smart people from Sun Microsystems. So today, our entire Oracle Cloud data centers, they're mostly all Sun machines. That's how we run our cloud today. And by 2016, we were able to give the first bare metal cloud for our customers. And as we move forward, we started deploying, like our NVIDIA GPUs, Intel CPUs, AMD CPUs for our customers. And today we also have ARM-based CPUs on OCI. So we started this cloud 4 to 5 years back, but again, if you look at our history, that's how it helped us move to the market very fast. The most interesting slide, this looks like a big box, but this is what we do very special in Gen 2 cloud. We have what we call the bare metal. You do have, just like any other cloud, we provide virtual machines, but you as an HPC customer, most of you must be running this workload on-premise today, and you have bare metals on-premise. So that's why we designed Gen 2 on bare metal as the basis for our customers. So with bare metal, you get 100% utilization. You get equal or better performance on OCI because we give you the entire bare metal. And in the same bare metal, we have special networking. I'm going to speak a little bit on the networking side of the house, and we can run any of our chips from Intel, AMD, and NVIDIA. So this is an interesting slide. I like to talk about this because this is the core for HPC. So we have so many customers. So in this diagram, you can see CPU, GPU, and the way we build this infrastructure by special networking called RDMA. So we have remote direct memory access, what we call cluster networking. We can do it for both the CPUs and the GPUs. In case of the CPUs, we can deploy as big as 20,000 core, and these are physical core, these are not virtual cores, right? So that's how Oracle deploys our compute instances. So we can combine all of this CPU and make one cluster. That's what we call cluster networking. And between every 2 nodes, we just have 1.5 microsecond latency. So this is what you need as a customer. When you have a large HPC workload, you might need 10,000 core, and all the 10,000 core has to work together, and you need the highest performance. And that's how we beat everybody else in the market, because we have this special networking. We can also do the same with GPUs. We have today a large language model running on OCI. We can span up to 512 GPUs. We can even go more if required. And each of these GPUs leverage the same technology, the cluster RDMA networking, and that's how we build big clusters or huge clusters for running very big GPU-based workload on OCI. Well, apart from the HPC, obviously this is standard. We do have virtual machines. We have platform services. I talked about the SaaS layers. So this is the core of the Gen 2 cloud. So the way we have designed our machines, our instances, or our networking, this is the crux of it. So we do offer off-box virtualization. So what it means is we don't run the virtualization layer on the same machine that we provide to our customer. We have a special networking gear just below the bare metal that provides the off-box virtualization. We do provide what we call a zero trust custom chip. So what it means is every time, it's multi-model, obviously. So every time we give you new virtual machines, we give you a zero trust approach. That means when you run your code, you can be rest assured that it's all secure. Non-blocking networking, I'll speak a little bit more on that. You have access to L2 networking. This is for VMware use cases, for databases. RDMA, I just talked about it, and flex infrastructure. This is pretty interesting. Unlike others, where they have t-shirt size shapes, in the current generation that we have today, you can really flex your shapes. So for example, you can just say, hey, give me 8 core and give me 36 gigabyte of memory. So you can really flex and exactly get what you need. You don't need to buy any t-shirt size. That's what we offer in the cloud. Well, this is, again, typical networking architecture, how we build our entire network. One thing I can just talk about this slide is there's no more than 2 hubs between 2 machines. This is how exactly we have built our Gen 2 cloud. So just not our HPC infrastructure, you also get very high performance from a regular infrastructure. So if you have a virtual machines, which does not take care or take advantage of the RDMA, you still get very high performance from OCI. Quick, maybe I'll touch on some of the compute infrastructure that we have. As I mentioned before, we do support Intel, AMD, and ARM processor. Maybe this slide is much better. So we have the latest and greatest, the EPIC standard instances for AMD. We have the Skylake processor for Intel, Ampere ARM, NVIDIA GPUs. So I talk about the price performance. So what we have today is our latest generations, but we have not changed the pricing from the previous generations. You do have access to our previous generations also, but then as we roll out new processors in the market, we have not changed the price. So every of these new processors actually are more than 30% faster than the older generations, by the way. So straight away you get 30+ performance. At the same time, the price is the same. So that's really about price performance that you can get out of OCI. Well, this is some of our NVIDIA GPUs capabilities. We have all different generations. The latest generations is the A100 from NVIDIA. So this is where you run large multi-model training. The V100s are very good for inferences, and the P100 is the older generations. There are people still using the P100s today. So this is just the A100, how we built, again, I mentioned earlier, we can also build huge clusters to our A100 GPUs. If you are thinking about running large model training, Oracle Cloud actually provides the fastest, networking speed between multi-node GPU clusters. So we work very closely with NVIDIA. They're great partners for us, and we have seen the great progress in this market. So we have a lot of customers who are running large training and model in OCI as of today. So before I give it to Brian, I want to maybe switch a little bit onto another slide, maybe a website. I just want you to hear from a customer directly. Whatever I told you, right? We have so many customers story that we can talk about. So I want to play a video from Nissan. You want to hear whatever I told and how the customer feel about it, right? So I just want to make sure we are seeing the same story. So give me 1 second. I will just play this video. Let me know if someone can hear the voice.
Since 1933, Nissan seeks to provide unique and innovative automotive products and services that delivers superior and measurable value to all our stakeholders. Nissan is a leader in adopting cloud-based high-performance computing for large-scale workloads such as crash test and computational fluid dynamics simulations. Running large CFD and structural simulations requires tremendous amounts of compute power. Nissan has adopted a cloud-first strategy for its HPC platform to ensure its engineers always have the compute capacity needed to run their complex simulations. We selected Oracle Cloud Infrastructure High-Performance Compute Solutions as part of our multi-cloud strategy to meet the challenges of increased simulation demand and under the constant cost savings pressure. By moving our high-performance and latency-sensitive engineering simulation workloads to Oracle Cloud, we will be able to speed the design and the testing of new cars.
I just want to give a testament from one of our customers, so that's why I just played that video. But Nissan runs their entire HPC workload on OCI. You name any car manufacturing companies, most likely they're running today on OCI. So another customer that I can refer publicly is Toyota. So Toyota also runs their entire HPC solutions on OCI today. Well, that's one more slide which I missed here. This is mostly around our file systems. So as Riaan mentioned, they do support multiple file systems, so do we. So as you deploy your HPC solutions through Moab or ODDC, you can build a parallel file systems based on IBM Spectrum, BGFS, Lustre, whatever you want to bring into OCI. We do have one of the fastest file systems in the world, actually. If you go to IO.500, you can see Oracle listed as one of the top file system in the world. Well, again, compliance, we do have all compliance certifications. We can talk more as required, from government to, PCI to HIPAA, any kind of workload we can run on OCI today. Well, Brian, do you mind going through these next 3 slides?
Sure. Can everyone hear me?
Yep.
All right. So it's my job to make charts and graphs not only look interesting, but sound interesting. Now, I want to start by bringing up a benchmark that was done by a third party. Okay, so we invited Exabyte.io, which is a cloud-based nanoscale modeling platform that accelerates research and development of new materials to test the high-performance computing capability or hardware of Oracle Cloud Infrastructure. Now, as Exabyte.io seeks to provide their customers with the highest performing and lowest cost modeling and simulation solutions, they have done extensive research and benchmarking with cloud-based HPC solutions. Now, the latency graph on the left shows the raw ping pong numbers for each cloud provider. We had the lowest latency of any cloud provider because of our RDMA networks that Anup mentioned before. The latency stayed consistent at around 1.5 to 1.7 microseconds until about the 2048 byte packets is where it starts to increase. You can also see from the other graph that our bandwidth was significantly higher as well. These graphs represents the performance of Oracle RDMA networking versus the highest speed networking of AWS, Azure, and Google. Oracle offers the lowest latency and highest throughput compared to those other cloud providers as well. Can we go to the next slide? So when it comes to how we perform specifically in the HPC space, right, we don't really consider ourselves competing against the other cloud providers. What we're actually competing is the performance of on-premise solutions. When we first launched our HPC platform, we were coming out with the HPC 2.36 shape, which was comparable, if not better, to on-premise solutions that customers had, and it outperformed the other cloud providers. But this isn't a forum to focus on how we're better than other cloud providers. What I want to do is showcase how we are even innovating even more when it comes to what we can provide with our new X9 shape. So we created a cluster for this benchmark of bare metal HPC VM optimized 336 instances using a stack in the Oracle Cloud Infrastructure Resource Manager. Now, this stack contains all the parts that turn a collection of instances into a functional HPC cluster. The stack can add network file share, NFS share volumes, extra block volumes, or another file system such as OCI file storage service. And for our tests specifically, we used 3.2 terabytes of local NVM as a shared NFS volume amongst all the nodes. This stack also installs the Slurm scheduler, which we use to perform our benchmarks. And that's the test bed that we use for, this graph and the following graph. For this particular graph, we ran ANSYS Fluid R2 2020 with the embedded Intel MPI 2018 for the race car 140 model. Now, what this model does is it simulates an external flow over a Formula One race car that has around 140 million hex core cells. This model uses the realizable KE turbulence model, which is a pressure-based couple solver, least square cell-based, and pseudo-transient solver. Ooh, sorry, that was a lot. So what you can see is that this model is approximately 30% faster on our X9 platform, the 3.36, when compared to our 2.36 with near perfect scaling on 72 to 576 cores. If we're looking at how many nodes, that would be around 2 to 16. So as an HPC user, right, you're going to get 30% cheaper and faster results just switching from our X7 platform, which was dominant in the space, to our new X9 platform. And the exact number will depend on the model that you run. Can we switch over to the next one? All right, so for LS Dyna, we were doing the car-to-car simulation, which is a head-on collision that occurs between two vehicles. For this benchmark, we modified this test to shorten the end time to 0.01 seconds. We see performance gains of approximately 20% compared to our previous, generation X7 bare metal server across a wide range of core counts. So ultimately, when you're looking here, you're seeing 20% cheaper and faster results. Once again, however, the exact number depends on which model you run.
Brian.
Hey, Brian.
Yes.
Yes.
We have a quick question, if you can, from an attendee. What is rating on the ordinate slice fluent case?
And Brian, just out of interest, this is Gert Linden from PTB that asked the question.
Okay. So typically, the higher rating is better. I'm not a specific, ANSYS Fluent, expert, right? But when I reach out to our HPC benchmarking team, generally the higher number you have, the better it is. But I can definitely follow up to get a more cohesive answer from an expert on specifically, what the rating means.
Okay, great. Thank you.
So I think we are running out of time. I just want to have this last slide. As I mentioned, we have almost every car manufacturing company running on OCI today. I have a lot of customer references slide, but we won't have too much time to talk about. With that being said, thank you everybody for hearing from Oracle today. Thanks Sue and Riaan for inviting us to this webinar. I'll hand it over to you back.
Thank you very much, Anup. Thank you for you and Brian as well. So thank you, Sue. If you want to take over from here, but thank you very much, Anup and Brian. Very informative. Thank you for you guys' time as well.
Okay, Riaan, thank you very much. I guess we're going to conclude our webinar for today. So again, thank you for your interest. Thank you for taking time out of your busy day to join us. For more information, please contact us at Adaptive Computing, info@adaptivecomputing.com. You can contact us by email or by phone at 239-330-6093 or on our website, and we'll be happy to help you and customize a solution for you. So once again, thanks and have a great day.